Hi, welcome to the first page of Advanced Functions for Math Applications. First page is about piecewise functions. Piecewise functions are, in our case, basically lines that are connected together to make like a shape that's like jagged lines, so you can change direction in the middle of it. This is useful for the reasons that we showed in the investigation, that sometimes in real life you have things that behave like lines in certain intervals and then behave like another line in a certain interval. So you can put lines together in the same function. And the way you do that, of course, is that you define your lines on the left here, and then you define like the interval that this line is valid in here, and you always define the interval with respect to x. Okay? All right, so let's begin. So for the first one, it says, for each of the following piecewise linear functions, state the domain, plot the graph, and find f of 3 and f of negative 3. And remember that when you have the expression f of something, the inside thing is actually the x value, and when you talk about f of the x value, you're talking about the y value. So you have f of x equals 1 plus x for this interval from negative 3 to 4, and 9 minus x for this interval 4 through 10. And you notice that sometimes we're using less than or equal to, sometimes we're using less than. Basically, whenever we define like the left and right edges, which in this case are negative 3 and 10, those are like the smallest and the largest value, we are using less than or equal to because we're defining the function right up to negative 3 and right up to 10. But then when we talk about the middle value of 4, you notice that one of them has less than or equal to 4, and the other one has 4 is less than. Only one of them is less than or equal to. The other one is less than. And the reason why they do that is because they don't want to say that it's equal to two different linear functions at the same point. So they decide, okay, let's decide that this function is the valid one for x equals 4, and this one is not. Okay? Or vice versa, it doesn't matter which one, because as you can see, if you put 4 into this one, you get 5. If you put 4 into this one, you get 5, because 1 plus 4 is 5, and 9 minus 4 is also 5. So usually with these piecewise functions, the point at which they meet gives you the same y value, so it's actually the same point, so it doesn't really matter if it's the first function or the second function at x equals 4. But it just has to be one or the other, not both. Okay? All right. So in this particular case, remember that these linear functions can be broken up into y equals mx plus b. So for example, this one here, mx would be 1x because there's no number in front of the x, so it must be 1. So the slope here is 1, and the y-intercept is also 1. For this one here, the slope is negative 1 because we have negative x, m is negative 1, and then the y-intercept is 9. Okay? So let's graph this. Oh, state the domain. So the domain of this piecewise function, it goes from the smallest value, negative 3, to the largest value, 10. So the domain in this case would be x is, x is between negative 3 and 10. Okay? And then it asks to plot the graph. And we're going to do that right here. We'll put A up here at the top. As you can see, I made a mistake on the initial grid. I didn't give enough space, and now it's fixed. So we are going to graph from negative 3, which is here. Each grid marker is labeled with numbers just every 2 units, so don't be confused by that. The right interval limit would be 10. And if we were going to graph the line 1 plus x, that is equal to 1x plus 1, right? Where m is 1 and c is 1. So that means the slope is 1 and the y-intercept is 1. So if the y-intercept is 1, it's going to go through this point here. If the slope is 1, it's going to go over 1, up 1, over 1, up 1. And this function, 1 plus x, is valid from -3 to 4. So I'm going to do that from x equals -3, which is here, all the way to x equals 4, which is here. Okay? So basically, I'm going to graph this line between the left edge of -3 and the right edge of +4. And then I'm going to change to a different, color, because I'm going to now use the 9 minus x. I'll use green because the grid is kind of blue. I'll use the function 9 minus x between x equals 4 and x equals 10. And so this, if I put it in the order mx plus b, would be -1x plus 9. So the slope is -1 and the y-intercept is 9. So this is kind of hard to see because 9 is off the edge of the page. But we could just put in some numbers to see what the points are for -1x plus 9. So I'm going to do that. Since, 9's way up here, it's hard to graph it using the y-intercept. So I'm going to put in a few points like 0, 1, and 2. Oh, not 0, 1, and 2. That makes no sense because it's not valid from 0, 1, and 2. It's valid from 4 through 10. So how about if I just put in numbers that are between 4 and 10, okay? So I'm going to put 4, 5, and maybe 10, okay? So if I put 4 in there, it's going to be 9 minus 4 is 5. If I put 5 in there, it'd be 9 minus 5, which is 4. And if I put 10 in there, it'd be 9 minus 10 is -1. Okay? And of course, you could also do this by putting it in the calculator. If you put it in the calculator, you're going to put it into y equals. And then we're going to put in 9 minus x. And then we're going to look at the table. And then just ignore the numbers x equals 0, x equals 1, x equals 2, x equals 3, because this function is only valid from x equals 4 to 10. So then you just look at, 4 corresponds to y equals 5, 10 corresponds to y equals -1, etc. So same thing, right? So 4 comma 5 would be this point here. Oh, what a coincidence. They meet at that point. 5 comma 4, it's here. And 10, -1 is here. And so basically we could draw out the points in between because it's a slope of -1, which means it goes over 1, down 1. So basically the right side of it looks like that. That's not a very good drawing. It's hard to use a ruler when we have these digital pens. Okay, so that is the function for 1a. Now for the function for b, it defines the function as the line x when x is greater than or equal to 0, and the line -x when x is less than 0. So let's just use the calculator to plot that. Although this would be the line mx plus c, it would be 1x plus 0, so the slope would be 1 and the y-intercept would be 0. So I'm just going to put x here, and then I'm going to look at the table. And so basically the y value is the same as the x value because y equals x, right? So I'm going to graph those points, and this is valid for x is greater than or equal to 0. Oops. Do that in red. And where does it stop? Oh, by the way, it asks the domain. What is the domain for this function? Well, it never says that it stops at 10. It actually goes on forever. So actually, x goes on forever to the right. It goes on forever to the left. So the domain for the function in part B is that x is all real numbers. Okay? And let's see, so that would be x is greater than or equal to 0. It would be this here, and I'm going to put an arrow showing that it goes on forever. And for the negative x part, that would be a line, which and make sure you use this negative, not this minus sign. Look at the table. And we're looking at the values where x is greater than 0, so we're going to look at values like 0, 0, negative 1, 1. So 0, 0, negative 1, 1, negative 2, comma 2, etc. Right? So it makes like a V. Okay, so that would be 1b. Let's go to the next one. Now in this one, they're doing the opposite. They're giving us the function's graph, and we're going to figure out how to write the function. So let's see, for this function in part A, let's see, part of the graph is from negative 4 to 0. So that would be this part here, right? And what is the equation of this line? Well, the y-intercept is 5, and the slope is plus 1 plus 1. 1 divided by 1 is 1. So it would be 1x plus 5, right? The slope is 1, over to the right 1, up 1, and the y-intercept is 5. So it's 1x plus 5. And then this other part here, it goes between 0 and 3. So 0 and 3. And the slope is obviously horizontal, so that would be a slope of 0. So it would be 0x plus 5. So basically 0x is 0. So basically the function to the right of the origin is going to be y equals 5, which is a horizontal line at height 5. So we did that one. Let's do B. So for this one, let's first analyze this part here. This part ranges from x equals negative 2 to x equals 2. And the slope is down 1 to right 1. So that would be negative 1 divided by 1, rise divided by run. So that would be negative 1x, and the y-intercept is 3, so it would be negative 1x plus 3. And that is between the interval negative 2 and 2, so this would be negative 2. Then we're going to do this side of it. So this side of it goes from 2 to 4. Notice how this 2 is the same as this 2. And this function, it looks like it would be a slope of 1, right? And the y-intercept would be negative 1, right? If I extended this, the y-intercept would be negative 1, right? So I'm going to put positive 1x minus 1. Okay? All right. Let's go to the last part, number 5. Consider the set of data points in this table. Plot these points on a scatter diagram. Find a piecewise linear model that best fits these data points, and draw your model on the same set of axes used for part A. Hence, estimate the value of y when x equals 8 and x equals 15.5. So we're going to do this on a piece of grid paper at the end of the packet because there's not really enough space to do it here. Okay, so if I look at my data, looks like the smallest number in the x data is 1, and the largest number in the x data is 18. So I should go between like 0 and 20 or so for the x. For the y values, looks like the smallest data is 2, and the largest data is 15. So I should go at least up to 15 for that. So let's make a little grid here, and 20 and 15, those are pretty small numbers, and this grid paper has a lot of squares, so I could just do a grid that goes from 0 to 20, counting by ones, and the y-axis counts from 0 to 15. Remember, to make your life simple, either count by 1s, 2s, 5s, or 10s. So in this particular case, I'm just going to graph these points here. 1, 5.3 would be slightly above 5 right there. 3, 4.8. Here's 3. 4.8 would be slightly below 5. 4, 4 would be exactly there. 6, 4.2 would be slightly above 4. 7, 3.4 would be slightly above 3. 9, 3.1 would be slightly above 3. 10.5, 3 would be right there. 12, 2 would be right there. And let's see, 13, 4 would be here. 15, 37.3 would be slightly above 7. 14, 8 would be right there. 17, 11.5, 17, 11.5 would be right there. And 16, 11, 16, 11 would be there. And 18, 15, that 18 would be here. 15 would be the top value there. So you can see that this looks like, to match a function with this, looks like it's a line, but you know, it looks like there's a one of the lines is here, and the other line would be like here, right? So maybe what we could do is we could take all the points, all the yellow points, and include this point here, and then we'll do a linear regression for that, get an equation for a line. Then we'll do the same thing for the green points. And then we'll have two separate lines that we have found with the calculator's linear regression function. And then that would help us make a piecewise function for this kind of a real life problem here. This is something that people have done in their IAs with great success. Okay, so remember to do linear regression, we're going to use stat edit. So we're going to go to stat edit, and we're going to put, I'm going to put all the numbers that are the yellow numbers. So basically the numbers from x equals 0 to x equals 12. So I'm going to go all the way up to here, in between all those. And then I'm going to put the green numbers in separately, and we'll do that afterwards. So first I'm going to go put all the yellow numbers into stat edit, and then I'll be right back. Okay, so I went into stat edit and I typed in all the numbers from x equals 1 to x equals 12, including their y values. Now remember to do linreg. I do stat calc linreg, which is number 4, and I put L1 and L2 because that's where I put my data, and make sure frequency list is blank, and then I go down to calculate. And my yellow line equation would be the slope of negative 0.270 x plus 5.50. Okay, and now I'm going to do the green data, starting with 12,2. So I'll be right back. Okay, I put the green data in list 3 and list 4 just so that I would have the yellow data in there still. And I do stat calc, and since I put it in list 3 and list 4, I need to do stat calc linreg, which is option number 4. And I'm going to put L3 and L4 here. So I'm going to put blue L3, And then for Y list, I'm going to put blue L4. And then I'm going to do calculate. And then the equation for the green data is y equals 2.04x minus 22.1. Okay, so I got two equations here. And the only thing I need to do now is I need to see where exactly the two lines intersect, because they're not going to intersect exactly at 12,2. Okay, so the way I can see where they intersect is I can put each of these equations in the calculator in the y screen. 270x plus 5.5 is the yellow data, and the green data is 2.04x minus 22.1. And then I graph, and it's going to look kind of like my drawing here, except it's off the edge of the screen. But if I change my x-axis to 0 to 20, it should be about right. So there's my yellow, and there's my green. But remember, the yellow, I only want to consider this part here. The green, I only want to consider this part here. So we need to know what is this x value here. So the way we do that is we do second calc intersect, right? Number 5. First curve, second curve. Yes, we just hit enter 3 times. The intersection is 11.95, comma 2.27. So it's close to 12,2, but it's not 12,2. So we'll put that the intersection point for the yellow and the green is going to be 11.9, comma 2.27. So when we define the function, we're going to use this line and this line equation, and then this 11.9 value here. So let's write that. I'm going to show you how to write that answer down. Okay, so we've gone back to page 1 to write down our answers. And first it says to plot these points on a scatter diagram, which we did on the other page. Find a piecewise linear model that best fits these data points. Yes, we have these two equations, and I'll just write them here. So we have the yellow equation. If I write this in yellow, is it going to show up? Not very well. Plus 5.50. And then we have the green equation, which is y equals 2.04x minus 22.1. Okay, so those are the two equations. And then in order to write it as a piecewise, we put f of x, we write equals, and then we do a bracket. And then we define the yellow part, for example. We don't have to write y anymore because the y is here, right? 270x plus 5.50. And that is true for the interval, let's say it's true for the interval 0 to 11.9. So we'll say when x is between 0 and 11.9, and then it's equal to the green function when x is between 11.9 and I think like 20, right? So do you notice how I put a a less than here and a less than or equal to here, so that 11.9 wouldn't be in both intervals. So that's the answer to B. And then C, draw your model. It's really hard to do that without a ruler, but I did that on the other grid with a highlighter. Okay, but if you did it with a ruler, you just need to make sure that your line goes through 11.9 comma 2.27, which is the intersection point, right? Hence, estimate the value of y when x equals 8 or when x equals 15.5. So we could do that using the calculator trace function, right? So let's do trace here. And it's saying trace with the function y1, which is the first one. And let's see, when x equals 8, it is on the yellow function. So, yeah, it is. So, and then we're going to press 8. Okay, and it tells us that the y value would be 3.34. Oops. 3.34. Okay, another way to do it would be to do table. And then since we're looking at the y1 function, which is the yellow function, we just go to x equals 8. And then we see that the y1 value is 3.34. And then the 15.5 x value is within the second interval. So that would be the green function. So that would be y2. And then I just go down to, oh, they don't have 11.9 here. So the way I can get 11.9 here is I could do plus 0.1, and that'll jump by 0.1s instead. And then I could go to exactly 11.9. Oh, I don't want 11.9, I want 15.5. 15.5. And if I go to 15.5, then the green value is 9.52. So 9.52. And there would be another way of doing that. I could do that with trace, right? I could go trace, and then instead of y1, I want y2, so I will use one of these arrows. I switch it to the green function. And now I'm going to type in 15.5, and that will take me to the appropriate point. Yeah, 9.52. Okay. That's it for page 1.